Hello everyone, today we're going to take a closer look at Global Warming by Seymour Simon. This was an expository text that focuses on how a change in climate can affect living things. Now, global warming started by giving us an introduction to what we would be reading about, and I wanted to point out the very last paragraph. Why is the climate changing? Could Earth be getting warmer by itself? Are people doing things that make the climate warmer? What will be the impact of global warming? Can we do anything about it? This last paragraph of our introduction is all questions. Sometimes authors will organize the introduction of an expository text with a series of questions. The idea is they will usually give the answers to these questions as you read. So they're really designed to help make you think about what you're going to be learning about. Okay, so we're going to go ahead and get started. We're going to focus our discussion on comparing and contrasting ideas, since that was our comprehension skill. Global warming is happening because of the greenhouse effect. A greenhouse effect is a house made of glass. A greenhouse is a house made of glass. The glass lets in sunlight but keeps warm air from escaping. Earth is not a greenhouse, but certain gases in the atmosphere act like the glass in a greenhouse. Sunlight passes through Earth's atmosphere and warms the ground. Some of the heat bounces back into space, but much of it remains trapped near the ground by carbon dioxide, water vapor, and other greenhouse gases in the atmosphere. The greenhouse effect helps make Earth warm enough for life to exist, but if greenhouse gases are released into the atmosphere in larger amounts, much faster than before, then the warming will get much stronger and the climate will noticeably change. So one of the things that I want us to look at to compare and contrast is these first two paragraphs, which talk about greenhouse gases and the Earth's atmosphere. And so we can actually compare and contrast because it tells us that they're different, but they're the same in some aspects. So, scooch my book over. That's the first thing that I want to compare and contrast. So I'm going to use my graphic organizer. Now, if you're at home and you're following along, you can also draw this graphic organizer so that way you have this information as well. But I want to compare a greenhouse to the Earth's atmosphere. So my question that I'm thinking about is, how is Earth's atmosphere similar to a greenhouse? How is it different? So when we read, we know that a greenhouse traps heat with glass. So again, I'm just going to draw a little picture. So this is, let's say, my greenhouse, and the roof is made of glass. So that way when the sun is shining, all that heat goes in, and then those gases get trapped. Okay, and so what does the Earth's atmosphere do? Well, it also traps heat, but not with glass. So it traps heat with gases and water vapor. My pen. With gases. It's dying. With gases and water vapor. So you might be thinking, okay, well, they're similar. They both trap heat. And you're right. That's what goes right here. They are alike in that they both trap heat. Okay? The main difference, what makes them different in this particular section, is that how they trap that heat with glass, with gases, and water vapor. So that's how we can compare and contrast. So as you read that first section, if you're kind of unsure how things work, your mind can start comparing and contrasting. Okay. Most scientists agree that something different is happening now. While Earth's climate has always varied, it is now changing more rapidly than in any other time in recent centuries. Since we have been keeping weather records, 19 of the 20 hottest years ever have happened since 1980. For thousands of years, the balance of greenhouse gases in the atmosphere had not changed much. But now we burn huge amounts of coal, oil, and natural gas to generate energy. Every year, billions of tons of carbon dioxide pour out from the exhausts of cars, trains, tracks, airplanes, buses, and ships, and from the chimneys of factories. There is 30% more carbon dioxide in the air than there was 150 years ago. Trees, like other green plants, convert carbon dioxide into oxygen. Okay, so we're going to explore this little section. When we got to paragraph 2, we learned something. For thousands of years, the balance of greenhouse gases in the atmosphere had not changed much. And then as we keep reading, we learn that because of all of these things that we as humans are now doing, there has been a change. So that's what we're going to compare and contrast here. I'm trying to make it, I wonder if I could do this so we can see both. Okay. So I gotta get my blue pen. Okay, so we learned that atmosphere for thousands of years, there was minimal, which means not a lot, minimal changes in greenhouse gases. And then as we went down further, we learned that the atmosphere now there is 30% more carbon dioxide in the air. Okay, and you might be wondering, okay, well, how are they alike? So if we think about what these two things have in common, the atmosphere for thousands of years, and the atmosphere now, this one had greenhouse gases, just not a lot of them. And this one, carbon dioxide, is a greenhouse gas. So we still see there's greenhouse gas. So we know that in the atmosphere, there was still a release of greenhouse gases. So again, when you're reading, if you're unsure about how concepts connect, you compare and contrast. How are they different? How are they alike? Sorry guys, gotta get organized. Okay, so now I want us to think about how Alaska has changed in the past few decades. That's what I want us to think about for compare and contrast. How has Alaska changed? So I'm going to start down here. Glaciers and mountain snow covers are rapidly melting. Almost every glacier in Alaska is receding. A few decades ago, huge rivers of ice stretched over the land. Now, hundreds of feet or sometimes miles of bare rock and soil are exposed. In 1963, the Mendenhall Glacier Visitor Center in Juneau opened, very close to the glacier. Today, it is a mile or more away from the frozen edge of the retreating glacier. Okay, so in the beginning of this paragraph, we learn what's happening. Glaciers and mountain snow covers are rapidly melting. Okay, so that's what's happening. We learned that almost every glacier in Alaska is receding, which means, moving back. And then here we go, a few decades ago. So what was Alaska like a few decades ago? Huge rivers of ice stretched over the land. Okay, now our signal word is now. That signals a difference. That's what it was like decades ago, and now we're going to learn about what's going on. Now, hundreds of feet or sometimes miles of bare rock and soil are exposed. Okay, so we have our compare and contrast. So, decades ago, huge rivers of ice stretched over the land. Did I say rivers? Yeah. Huge rivers of ice stretched out over the land. And we learned that Alaska now rock and soil are exposed. Rock and soil are exposed. And we also know that glaciers are receding. Okay. And then, how are they alike? Well, they both have snow and glaciers. It may be different amounts of snow and glaciers, but that is still a common factor. They're still present. They have just changed. So both have snow and glaciers. Okay, we're going to move into our last part here. Let me get my book so we can see. Got to make sure we've got both sides of the story. Okay, so these two sections talk about temperatures rising and what happens as temperatures rise, more specifically in tropical regions and in dry regions. Okay, so when we look at these sections, we want to think about how tropical regions and dry regions are being affected by rising temperatures. As temperatures rise, the level of oceans will rise. A recent study found that if temperatures rise by 3 degrees Celsius, Greenland's enormous ice sheet will begin to melt, and sea levels all over the world may rise by a half foot to 3 feet or more. This may happen over years or decades, or may take longer than a century. A 3-foot rise in sea level could swamp the Gulf Coast and every East Coast city from Boston to Miami. Rising water would cover low-lying areas such as the Nile Delta and countries such as Bangladesh. Millions of people would be forced to move. The Antarctic ice cap holds about 90% of the world's ice and about 70% of its fresh water. It does not look as if the entire ice cap will melt anytime soon, but if it does happen, sea levels would rise 20 or more feet. Now that would cause major flooding in coastal areas. Okay, so this spoke more to sea level, okay, and how that's rising. But I don't quite know if that section spoke to a difference in tropical land versus dry regions. So I'm going to read my next section. Atmospheric warming, so the atmosphere warming, can cause a rise in ocean temperatures and place coral reefs in jeopardy. Coral reefs are huge branching structures made of limestone. Okay, this is all about coral reefs. Don't say anything about tropical regions or dry regions. So I'm going to move. I'm going to scan. Scanning is a great trick when you're looking. I'm looking for words like tropical regions, dry regions. Let's see. Okay. Climate change affects every ocean and every continent. Rising temperatures add heat, energy, and water vapor to the atmosphere. That can lead to heavier rainfalls and more powerful storms in some places and long droughts in others. Okay, wait. Heavy rainfall in some places, droughts in others. Compare and contrast. The changes will differ depending upon the location. Many tropical areas may have greater rainfall, but in dry regions, even less rain may fall. However, high temperatures will cause the soil to dry up and terrible droughts may ensue. Okay, we have our information. So we know that in tropical regions, may have greater rainfall, and in dry regions, less rain than normal, causing droughts. And what's going on in both of these areas, how they're alike? Temperatures are rising. And how about both still receive rain? Okay, so those are some examples of how to compare and contrast elements of the story. Now, you could go through, we did 4 examples.